Okay, let's get going on this lesson for P1 out of your textbook. Hopefully this is working so that you are going to be able to hear me at home. Let me get the slideshow going here in full screen. I guess we're going to have to deal with that in the corner. Okay, so a review of real numbers and their properties. Okay, here's those definitions that we were kind of referring to in class today. Natural numbers again, otherwise known as counting numbers, they're going to begin with 1 and go in the positive direction only. Whole numbers are very close to the same thing as that, except for they will also include 0. Integers are when we get to go positive or negative. Okay, none of these first 3 systems or sets of numbers include fractions or decimals. Now, once we get to rational numbers, the 4th one on the screen, all rational numbers can be turned into fraction form. Technically, that's called A over B form. And most of the numbers that we play around with are going to be able to do this. Okay, so most of the numbers that we work with will be rational. Irrational. These, of course, then are going to be numbers that cannot be converted into fraction form. Okay, we have very few things that are irrational. Pi, that rambles on into infinity, is irrational. Nothing that rambles on like that can be turned into a fraction. Non-perfect square roots, things like the square root of 3, are going to be irrational because those decimal values will ramble into infinity, much the same that pi does. And then, of course, the decimals that ramble into infinity without any kind of a repeat. So out of the 3 kinds of decimals, the weird ones are left to be irrational, but all of your terminating decimals, your normal ones, all of your repeating decimals that have the bar, they will be rational. Okay. Now, this section is going to be reviewing inequalities and how to order real numbers. One possible new concept is bounded and unbounded intervals for us. Now, you guys are going to notice that they deal with inequalities and graphing of inequalities a little bit different than you've been accustomed to. So take a look at the examples and see if you can't kind of follow through with their logic and their thinking for those. All right, open up your book so that you're on page 5 with me in the text. Notice that there's 2 kinds of interval notations. There's one that looks like just a regular parenthesis bar, and then the other one is kind of a squared off bracket. All right, the parenthesis looking one, or the curved one, means that the interval does not include the digit. Okay, so those will be your less than or greater than symbols. The squared off bracket means that the digit is included in the interval. Okay, so that's going to be your less than equal to symbol, or your greater than equal to symbol will get marked with that. Also in that text, again, like I was mentioning before, those symbols for the parenthesis thing, the bracket thing, those are used on the number line in this text as well. Remember, in the past, that's been open dot and closed dot kind of things on our number line. Now you're going to be using these bracketing types of systems. Okay, for example, graphing the following on a number line. If we have -3 is less than x is less than or equal to 5, look at the number line there, and there is a solid line. I guess I could have made that a little bit darker, that goes in between them. Notice that the -3 has the parenthesis kind of marking on it, and then the 5 has the squared off bracket on it. Okay, moving on. Another review topic that's going to be in this first section is absolute value.
Sorry for the interruption.
Sorry about that.
Excuse the 7th and 8th grade volleyball players. 7th and 8th grade volleyball players, please be excused. The JV football players, be excused at 3:05 today. And Kylie Swanson,
Sorry about that. All right, another concept again is absolute value. Remember that absolute value is a distance the number is from zero. Distance is never negative, so answers to negative or to absolute value problems are not going to give you negative results. For example, if you wanted the absolute value of 5, 5 has a distance of 5 from 0. If you wanted the absolute value of -5, -5 also has a distance of 5 from 0. Turn to page 7 now if you would. Okay, there's properties that are associated with absolute values. Okay, so in page number 7, you can see that the absolute value of A is going to be greater than or equal to 0. So in other words, you'll never get a negative answer. The absolute value of a negative number is the same as the absolute value to its positive or its opposite. Number 3, the absolute value of A times B is equal to the absolute value of A times the absolute value of B. And then number 4, it's the same kind of thing for quotients instead of multiplication. So the absolute value of A over B is going to be equal to the absolute value of A over the absolute value of B. Now, often throughout the course of this text, do you see how next to that number 4, that fourth property, it has B is not equal to 0? That's because notice where B ends up in those quotients or in those fractions, you can never have a denominator of 0. It makes the statement or the problem undefined. Okay. Absolute value can also be used to find the distance between 2 points. It says find the distance between -9 and 13, and you can see the example through there. I showed it to you in this example both forwards and backwards, putting the -9 first and the -13 second, and then vice versa, the 13 first and the -9 second. Just to show you that it didn't really matter which number you started from, the distance between them was going to be 22 either way. Now, the rest of this section deals with properties for algebra. So please turn to page 9 and review the box that is on that page. Okay, so notice all those properties listed there. I did not retype them all into a slide. I figured you guys could look at page 9 in your book and see them for yourself. Those names should sound familiar. Commutative property, associative property, distributive, identities, inverses, and such. They are properties that you have talked about off and on all the way since probably about 3rd and 4th grade. Okay, couple of things to note with commutative and associative. They only apply to adding and subtracting, or excuse me, adding and multiplying. What they do is they essentially tell you that you can change the order of additions and multiplications without changing your answer. How do you tell the difference between commutative then and associative? Commutative has 2 elements in the problem. So you're adding 2 numbers together or you're multiplying 2 numbers together, and you can swap that order without changing your answer. When you get into the associative property and having that come into play, that's when you get into bigger problems that have lists of things to add or lists of things to multiply, and you can group them in different orders. Okay, so they're almost the same thing. But commutative properties deal with 2 items being added or multiplied. The associative property is going to be 3 or more. Okay, so that's the main difference between those two. Actually, it's about the only difference between those two. Distributive property, remember that if you have a number outside of a parenthesis that you need to multiply, you're going to multiply that number by everything in the parenthesis. Additive identity property, if you add 0 to something, you still have the something left. Multiplicative identity, if you multiply something by 1, you have the something back. Additive inverse deals with opposites. If you add a number to its opposite, you're going to get 0 for a total. Multiplicative inverse, if you multiply a number by its reciprocal, you always get a total of 1. So that's just a review of a lot of properties. Again, you've seen them for many years. Maybe haven't completely pounded down the name of it with what it does. Mostly the focus is on understanding that it does what it does, and we'll try to polish those up and finish those off this year. Turn to page 10. There are more properties of negation found about halfway down page 10. Again, just review them. I'm not going to have you guys write all of these into your notes. If you just have references to page 10 or page 9, if you need to go back and figure out or remember the names of the properties, you can do that. You do not need to rewrite these all into your notebook. So these properties are going to deal with negating and equal different equality type statements. So if you just look through them, if you take a number times a -1, you're going to get its opposite. If you take the opposite of a negative amount, you will end up with a positive. Number 3 in that property box, a negative a times b is the same as the negative of a times the b is the same as a times a negative b. So if you have two items being multiplied and there's one negative sign in there, you're just going to get negative ab no matter what. So there's a couple of different ways to look at doing that. Number 4, a negative times a negative is always a positive of that product. Number 5 shows that technically with number 5, if you think about that, there's a -1 out in front of that parenthesis. So truly that one almost is like distribution. Okay, that negative distributes through the parenthesis just like a -1 would or any other number would. Number 6, if A is equal to B, then A plus or minus C is equal to B plus or minus C. So in other words, if you have two equal amounts to start with and you add something to both of them, you'll get still an equal amount. We use that concept a lot in our equation solving. You know, what you do to one side of an equation, if you do the exact same thing to the other side, you still have equal statements. Let's see, number 9, same thing goes with multiplication. If A times C is equal to B times C, then A must equal B. Okay, again, we use that in our equation solving. If you've got two statements and you can divide both sides by 2, the statement that you end up with is the same as what you started with before the 2 was taken out. Okay, properties of 0 is at the bottom of the page. I think those properties are kind of taken for granted a lot. Just be very watchful for that 0 in the denominator of a fraction. In that bottom box, it's number 4. Okay, all of those are going to be undefined if you have a 0 in the bottom of a fraction. All right, so the final part of the section deals with reviewing the operations of fractions, and you're expected to be able to calculate these without the use of your calculator. So the top box on page 11 reviews with you how you can do all of your fraction operations without using your calculator. And again, you're not going to get to punch these into your calculator for those sections. This is one of those things that came back on AccuPlacer and ACT results, is kids could not remember these basic number computations on their own. And so we're going to beef you guys up and make you a little bit stronger as far as fractions and decimals go. Remember, with your adding and subtracting fractions, you have to have a common denominator. Multiplying and dividing fractions, you do not. So please don't waste your time finding them. Multiplying fractions, you multiply numerator by numerator, denominator by denominator. Watch for that top to bottom cancellation. You can do that reduction before you multiply. It makes it a lot easier. Dividing with fractions, remember that you always take the reciprocal of the second fraction and then multiply. Okay? With both multiplication and division, you also may not keep a mixed number. It has to be turned improper before you begin. Okay, no mixed numbers to multiply or divide. Okay, I think as far as I have for you, that's going to do it. In class, we already talked about the fact that your assignment is going to be pages 12 through 13, the odds. So please feel free to start working on them tonight. Otherwise, we will have time in class tomorrow, and if you've got your notes all taken care of and jotted down, you've got the entire class tomorrow to finish working on them. So come and see me in the morning if you have any questions. Hopefully you guys were all able to access the video and I was able to attach it so we could have it. All right, have a good night, everybody.